Hey everyone, and welcome all you future CUET champions. You've clicked on the right video because today we are diving deep into one of the most high-yield topics in your entire chemistry syllabus, how to prepare alcohols. Trust me, you're going to want to stick around for this one. Let's get those marks locked in.
So let's be real for a second. Is organic chemistry giving you a hard time? Do you ever stare at a reaction and just get completely lost in the conditions? Yeah, I've been there. But guess what? You're in exactly the right place. In the next few minutes, I'm going to show you how to absolutely master the preparation of alcohols and turn this tricky chapter into your own personal mark-scoring machine. So you're not going to want to go anywhere because this is absolutely crucial.
Okay, so let's get right into it. The CUET Challenge, alcohols. Now you might be asking, why are we focusing so much on just this one chapter? Well, it's simple. The people who make the CUET exam, they love this chapter. Seriously. It's an absolute goldmine for questions that are super predictable and honestly, pretty easy to master once you know the secrets.
And look, this right here, this is basically your game plan. The exam isn't trying to trick you with some super obscure stuff. They're going to ask you to do these 4 things. Predict the product, tell them if the alcohol is primary, secondary, or tertiary, apply Markovnikov or Anti-Markovnikov rules, and spot the difference in reaction conditions. That's it. If you can master these 4 things, you've pretty much mastered the entire chapter. It is that direct.
So how do we do it? How do we master this? Well, we're going to break it all down into 5 super clear, easy-to-learn master pathways. I want you to think of these as like the 5 main highways that all lead to the same destination, making an alcohol. Ready? Let's hit the road with pathway number 1.
Okay, first up, pathway 1, starting from haloalkanes. This is probably the most straightforward one. It's a classic nucleophilic substitution. You just take your haloalkane, react it with, and this is key, aqueous potassium hydroxide. What happens? The halogen just gets kicked out and the OH group takes its place. Boom, you've got an alcohol. Sounds simple, right? Well, it is, but there's a huge trap here that catches so many students.
And here it is, the #1 CUET trap involving KOH. I am not kidding, this is probably the most common point of confusion in the entire topic. So listen up. If you see aqueous KOH, it leads to substitution, and you get an alcohol. But if you see alcoholic KOH, you get elimination, and the product is an alkene, a totally different product. So let's lock this in right now. Here's a little memory trick. AQ is for ALK. Alcoholic is for alkene. See that? AQ for ALK. ALC for ALK. Burn that into your brain. This one tiny detail can absolutely make or break your score on a question. It's that important.
All right, let's jump to our second pathway, making alcohols from alkenes. The main idea here is something called hydration. It's exactly what it sounds like. We're adding water. We're going to take that carbon-carbon double bond, kind of crack it open, and then stick a hydrogen on one carbon and an OH on the other. This whole process is super, super important because it's where 2 of the most famous rules in organic chemistry come into play. You absolutely have to know these.
Okay, get ready, because pathway number 3 is a total game changer. I'm talking about the Grignard reagent. Seriously, if organic chemistry had a superhero, this might be it. It is one of the most powerful, most versatile tools you will ever learn about. Why? Because this one reagent is like a master key. It can unlock primary, secondary, and tertiary alcohols. It all just depends on what door you use it on.
And this slide right here shows you the magic trick. It's so cool. The target you react the Grignard with completely dictates the kind of alcohol you're going to get. It's a simple recipe. You take your Grignard reagent and add it to formaldehyde, bam, you get a primary alcohol. You add it to any other aldehyde, you get a secondary alcohol. And if you add it to a ketone, you guessed it, you get a tertiary alcohol. It's a predictable pattern, and we're going to turn this into what I call a golden rule in just a minute.
All right, pathway number 4 is all about reduction. This is another way we can attack those carbonyl compounds, the ones with the C double bond O. All you have to do is add a reducing agent, something like sodium borohydride or LiAlH4, and the logic is super simple and consistent. Aldehydes always reduce to give you primary alcohols, and ketones, they always reduce to give you secondary alcohols. So again, the key is just knowing what you started with to know what you'll end up with.
And we've arrived at our final pathway, number 5, the hydrolysis of esters. Honestly, you can think of this as just an undoing reaction. You know how an acid and an alcohol make an ester? Well, this is just the reverse.
You take that ester, you add some water, that's what hydrolysis means, breaking with water, and you snap it back into its two original parts, the carboxylic acid and the alcohol. It's a really simple and direct way to get an alcohol.
Okay, great job. We've gone through all 5 pathways. Now we're going to switch gears and really zoom in on the specific rules that the CUET exam is going to test you on, like directly. These aren't just suggestions, these are the absolute non-negotiable points you have to have locked down.
This table right here, this is your secret weapon for the exam. I'm serious. You should pause the explainer right now and just stare at this for a minute. Maybe even take a screenshot. So the acid-catalyzed way follows Markovnikov's rule. The rich get richer, so the OH goes to the carbon that already has more stuff on it, the more substituted one. Hydroboration oxidation, with those different catalysts, does the exact opposite. It's Anti-Markovnikov. The OH goes to the less substituted carbon. You have to memorize the catalysts and know which rule they follow.
And remember how I mentioned a golden rule earlier? Well, here it is, the golden CUET rule for Grignard reagents. This is your ultimate shortcut for the exam. It's so simple. Formaldehyde gives primary. Any other aldehyde gives secondary. Any ketone gives tertiary. If you can just burn this simple table into your memory, I promise you'll be able to solve any Grignard question they throw at you in like 10 seconds flat.
Okay, you've learned the theory, you've got the golden rules, now it's time to see if you can use them under pressure. It's time for the practice question gauntlet. I'm going to throw some questions at you, and I want you to get ready to pause this thing and solve them. Let's do it.
Okay, here we go. First question up. What is the major product when propene is treated with water in the presence of sulfuric acid, or H2SO4? Look at the reactants, look at that catalyst. What rule are you going to use? All right, go ahead and pause the explainer right now and lock in your answer.
And the correct answer is B, propan-2-ol. Did you get it? The reason is that H2SO4 is the big signal for acid-catalyzed hydration. And what rules does that follow? Markovnikov's rule. So the OH group has to go to the more substituted carbon, which in propene is that carbon right in the middle. Awesome job if you got that one right.
Question number 2. Okay, check this out. We have a Grignard reagent reacting with acetone. Now, what kind of compound is acetone? It's a ketone, right? So, what type of alcohol are you going to get? This is a direct test of our golden rule. Go ahead, pause and think about it.
And the answer is C, a tertiary alcohol. Why? Because of the golden CUT rule. What does it say? A Grignard reagent plus any ketone will always give you a tertiary alcohol. No exceptions. See how quick that was? Knowing that rule makes these questions a piece of cake.
All right, we are on the final lap now. This is where we bring it all home. We're going to do a quick revision, and more importantly, I'm going to point out the most common pitfalls, the silly mistakes that can cost you easy marks. So I need you to pay really close attention here. This is crucial.
Okay, listen up. These are the top 5 traps that students fall into year after year. Number 1, confusing aqueous KOH with alcoholic KOH. We talked about that. Number 2, applying Markovnikov's rule when the conditions are clearly for anti-Markovnikov. Number 3, just completely blanking on the golden rule for Grignard reagents. Don't let that be you. You've got to be aware of these pitfalls so you can sidestep them on exam day and stay one step ahead of everyone else.
And here we are. This is it, the ultimate quick revision summary. Literally everything important we've talked about today is packed into this one single table. This is 100% your screenshot moment. Save this picture to your phone, put it on your wall, whatever you have to do. Review this right before your exam, and I promise you are going to be in fantastic shape for any question they can ask you on this topic.
And just like that, you made it through. You are now way better prepared to absolutely crush this crucial topic. So, I have to ask, how did you do in the practice gauntlet? Were you 2 for 2? Let me know your score down in the comments below. And hey, if this explainer helped you out, do me a huge favor and hit that subscribe button. Let's build this community of CUET champions together. Keep up the amazing work, keep practicing, and I'll see you in the next one.